Okay, now we're in section 30. In the last section, we've discussed, how to plot a point in a Cartesian plane, how to find the distance between 2 points in a Cartesian plane, and how to find the midpoint between 2 points in a Cartesian plane. So you should be very familiar with a Cartesian plane. Now what we're going to be doing is talking about graphing lines in a Cartesian plane. All right. So we're going to be given lines. The lines that you're given typically, I haven't seen otherwise at Essex County College, you're going to be given what's known as Diophantine, which means they're going to be really simple problems. You're going to have really nice solutions to them. Now, in general, Diophantine, at least historically, did not have simple ones, but I want to assure you, these are going to have very simple solutions to them. All right. And what the solution is Diophantine, we're going to be basically looking for points. We're going to be plotting points, and we're going to be graphing a line through those points. And we'll discuss that one step at a time. So again, I want to show you, we're going to be given simple examples. What I mean by that, they're going to be really simple numerical examples. We will certainly go through that though. I'm not saying they're simple and just dropping at that. I'll tell you why they're simple as we work through those. So in lecture, we will discuss about graphing a line. We'll give you good pictures. Hopefully you're looking at these pictures and paying attention to them. And you certainly, I'm not gonna say when I do these by hand, they'd be so good, but for the most part, if you have graph paper, your pictures should look relatively good. And we do provide graph paper to you. So, we'll go through this and we'll talk about, a couple topics that are related to lines, and there are special points. And the special points have names, and the names of those special points are x-intercepts and y-intercepts. Then we'll do examples. All right. So we're going to start by going to a whiteboard, and one thing at a time. It's going to be a short lecture, like most lectures are here. They're not long. At least in my opinion, not long. You may think they're endless, but they tend to be quite short. And I'll be going to the whiteboard. All right, let's talk about it. Graphing a line. All right, so I say, the graph a line, what you're going to do is you're going to be given an equation of a line. And let me point out what I mean by that. You're going to be given an equation between x and y that's known as linear. These are linear equations. The variables are not raised to powers other than 1. All right, let me outline what I'm looking at over here. I'm seeing an equation. It's linear in x and y. X raised to the first power, y's raised to the first power. All right, linear equation. So I'm going to say there's a relationship. It's a two-variable relationship now. Now, why we use an x and y? To remind you that we have an x-axis and a y-axis that we're dealing with. So I'm going to say probably the easiest thing you could do is come up with a table of values that would make this true. All right. Now, someone would say, I wonder what the numbers are. And again, I want to assure you this. We basically are going to pick very simplistic numbers. What I mean by that, integers that are on your fingers, like 0, that means no fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess I could go to 10, right? I could also do their negatives. All right, so let's take a look at an example. And someone says, where are these numbers coming from? My fingers. So I want to put this one down, and I'm seeing what they want me to put down. They say x to be 4. Whoops, sorry about that. X to be 4. And y is 0. Now someone says, where did they get that? I would not worry about that. All I can say is 4 is a finger number and 0 is a finger number. I want to see if it makes any sense. Now, this is where some students disagree with me. They say, no, I'm going to rewrite the equation. There is no need to rewrite the equation unless you want to. The equation is 2x. I'll write this down for you. Plus 3y is equal to 8. Well, I want to see if this makes sense. Well, what's twice 4 is 8, right? And what's 3 times 0 is 3? What's 3 times 0 is 0? Is 8 plus 0 equal to 8? Of course it is. Let's pick another one. And write the other one they put down. You may say, where are they getting these numbers from? Their fingers. So they put down -2 and a 4. You may wonder, I'm getting these from over here. Let's put this down. We like tables though. Well, I'm still plugging it back into this equation, and I want to see if that's true. What would you get? You get -4 plus 12, and that equals 8. That satisfies it. Let's put this one down. What do you get? -8, 8. Let's see if that's true. Well, you get -16 plus 24. Does that equal 8? It equals 8. This is good. They got another one over here. 10 minus 4. See if that works. 2 times 10, 20. 3 times minus 4 is minus 12. That equals 8. I got to be honest with you. Looking at this thing, I kind of think that it makes a pattern for me. And you may not like the pattern, but there's a pattern to this. All right, there's a pattern to this. I just want to briefly talk about it, but you don't need to talk about this. You can ignore this if you want. I'm just going to say it's a really simple pattern. I hope you look at these numbers, the x's, and you see it's minus 8, minus 2, 4, and 10. To me, they look like they're going up by 6. For example, minus 8 plus 6 is minus 2. Minus 2 plus 6 is 4. 4 plus 6 is 10. What would the next number be then? 16. I'll put this over here. Now let me look at the y's. More complicated, but I'm still looking at it. 8, 4, they're going down. What is it going down by? It looks by going down by 4. 8 minus 4, 4. 4 minus 4, 0. 0 minus 4, minus 4. Minus 4 minus 4, minus 8. You know what? I can see a pattern, but that doesn't mean it's true. Let's see if that's true. What's 2 times 16? 32. Minus, well, 3 times minus 8 is minus, right? 24. Does that equal 8? Yes. You could do this all day long, but my understanding of this is this. I want to stick with numbers that are really kind of simple for me. And I'm going to say the simplest one here for me to look at. Again, you may disagree with this, is 40. The next number I would look at is probably minus 2, 4. It's easier for me to look at. Why is that? Think about counting it. It's 2 and 4. The other one's 4 and 0. Right. The other ones for some students are really tough to count to, but I still want to go through it. We're going to be looking at these guys over here too. I don't think I want to do 16 minus 8, by the way. I'll tell you why. Graph paper generally doesn't extend that far for us. Like it usually goes to about 10 or so. Right. Let me look at my graph. I said 40 was the easiest one to do first. I'm going to plot that down for you. That's right here. That was really simple to do. How'd I do that? Origin, move right 4, don't go up or down. What's the other point I said? Minus 2, 4. That's right here. I got a claim that's also really simple to plot. 2 left, 4 up. What was the other point I said that you could probably do? Probably minus 8, 8. All right, I did that in blue, right? What do I mean by that? More difficult for me, but you go 8 left, 8 up, it's right over here. What's the other point I said that was pretty simple to do? Whoops, sorry about that. 10 minus 4, right? And where's 10 minus 4? Let's blow this up. Let's see, right up here, right? Whoa, sorry about that. I got a little confused there. How many points did I plot? 1, 2, 3, 4. My gut feeling, though, is this. If you can stick close to the origin, you're going to be doing a good job. Now, what do I notice about those 4 points over there? I noticed they lie on the same line. They're what's known as collinear. So what I want to do is I want to draw a line through those points. Now, what happens to a lot of students, they do something like this, and they say they drew a line. This is not a line. This is a line segment. Got to keep going on, right? This is still not a line. It's a line segment. So what we do is we keep going and we put an arrow saying it goes on forever. We keep going forever. What do? We draw a line through those points over there. How many lines, how many points do you need to graph a line? Only 2. What am I suggesting? Pick really, really easy points. What are easy points? Finger numbers. 0, 1, 2. Does it mean that 0 is going to work? No. Does it mean 1 is going to work? No. But I'm going to guarantee this. My experience at Essex, every single line they're going to give you is going to be a super simple integer solution problem. I want to stick with integers. I do know this, though. Some students like fractions. Nothing wrong with that. All right. Let me see if I've covered page number 1. Yeah, I think so. And I'm going to go, when I say page number 1, the first page in this topic here. Let's go to the next page. Next page, all they did was they graphed the line out for us. Let me blow that up for you. Much better. By the way, I'm going to put my little arrows in now. I noticed I didn't do that. All right, let's talk about special points. And they are special, by the way. And the reason they refer to them by name. All right, these are special. There's going to be 2 special points. One is going to be called an x-intercept. The other one's going to be called a y-intercept. Okay, I want to go back to the picture, and I want to emphasize, in the picture, I can identify what the x-intercept is. And I'll point this over here. This is the x-axis here. All right, this here is the x-intercept. Now, why they call it an x-intercept? It's where the line intercepts the x-axis. What is that point? Well, let's blow it up, right? It's tough, isn't it? So I'm going to say this point over here is going to be, well, it looks like 4 for x, right? And 0 for y. All right, here comes the tough one. I want to do the y-intercept. And I'm looking at it. And I'm going to say, although it's not there, when I mean the point's not there, I don't really see the point. The other ones definitely have these blobby looking black dots down there, and this one doesn't. So what I'm going to say over here is, I know there is. I know it. I'm looking at it. I know there's a y-intercept here. I know it. What I don't know is I don't know what the point is, though. What I could say is the value of the x has got to be 0. What I don't know is the y, though. And someone says, well, you know what? Let's blow it up and see if we can read that. Well, I'll be honest with you. If I'm looking at this and someone said, what's his value over here? I'm going to say, roughly speaking, this looks like 2, I'm going to say 2 2/3. Here's my problem, though. You're not going to be able to get this accurately read from any graph. So I want to go back to the original equation. Someone says, what was the original equation? And we'll go to the words later. 2x plus 3y equals 8. Write that down for you. 2x plus 3y is equal to 8. Well, I think I can do this point by looking at that equation. And why do I know that? If x is 0, what would I get? If x is 0, what would I get for the y? I don't know. You would get 0 plus 3y is equal to 8. Let's write this down. Y would be equal to 8/3. What's 8/3? 2 2/3. Well, you know what? I was pretty lucky, wasn't I? I got it right on mark. And what's that going to be? 8/3. All right, let's go back to the words. And we're going to read this to you. All right, there's also a video there for you if you want to read that, if you want to look at the video. The point, this is the next intercept now. The point at which, whoops, I always do that, don't I? The point at which the graph, in this case a line, crosses the x-axis. At the x-intercept, the y-coordinate is 0. To find the x-intercept, just set y to be 0 and solve for x. For example, let's look at this example here. And let's follow what they said to do. To find the x-intercept, all you have to do is set y to be 0. So let's do that. What do you get? 2x, I keep doing it. 2x minus 3 times 0 is equal to 6. 2x is equal to 6. X is equal to 3. Okay, so what's the x-intercept? X is 3 and y is 0. That's the x-intercept. It's a point. Let's do the y-intercept. Let's read it to you. the point at which the graph, in this case a line, crosses the y-axis. At the y-intercept, the x-coordinate is 0. To find the y-intercept, just set x to be 0 and solve for y. Well, let's do that. So what do we got? We have 2x minus 3y is equal to 6. What are we going to do now? We're going to set the x to be 0. So what do you get? Minus 3y is equal to 6. Divide both sides by minus 3, you get y is minus 2. So x is 0, y would be minus 2. What's this thing called? A y-intercept. We're getting it, all right? Now, by the way, let's read this to you. Sometimes you'll be asked to find one or possibly both of these points. Be aware that occasionally these points may be difficult to plot. Let me make sure you understand what I just said there. Be aware that occasionally these points might be difficult to plot. And I got to be honest with you, if they're difficult to plot, don't plot them. What I'm claiming though is even if they're difficult to plot, typically you'll always be able to find an easier point to plot, all right? So in those cases, I suggest you find easy points to plot. Don't worry, the graphs will include these difficult points anyway. For example, let's look at this guy over here. All right, I'll write it down for you. So it's going to be 3x. Let's go back to black ink. 3x plus 5y is equal to minus 1. I want to find the x-intercept first. Now, how do you find the x-intercept? Well, if you don't remember, go back and read the notes. All you have to do is set y equal to 0. Well, if you did that, what would you get? You get 3x equals minus 1. What's x? Minus 1/3. Okay, so I got my x-intercept. What is it? It's a point. What's the point? Minus 1/3, comma 0. Let's do the y-intercept. How do you do that? Fairly simple. How do you get a y-intercept? Set x to be 0. Let's do that. What do you get? 5y equals minus 1. What do you get for y? Minus 1/5. It's a point. What's the point? X is 0. The y is minus 1/5. Now, my claim over here is these points, although they can be plotted, tend to be quite difficult. Now, granted, I'm not stopping you. You can still plot these points. What I'm going to claim, though, is I would just look for an easy point to plot. All right. Now, how do I do that? I want to recommend to you, and again, a lot of students go against this advice. That's fine. You have to find something that works for you. You need to find a nice, easy number that's going to work for you. Now, someone says, what are the easy numbers? You could choose 0. I got to be honest with you. I've already done that up here, and they don't appear to be nice numbers. So I'd look for another number to choose. Someone says, what other numbers would you choose? Well, over time, you're going to get better by choosing numbers. I can't say it enough. Over time, you're going to get better at choosing numbers. If you don't choose numbers, though, you're never going to improve. So, you could choose 0, you could choose 1. Well, I'm going to try that. I'm going to choose 1 for the y. I'll write that down for you. I'm not going to say it's going to work. If it doesn't work, I get an eraser. I can erase it. What do you get over here? Let's write that down. 3x plus 5 equals minus 1. Well, it is more work, isn't it? So what do you get? 3x is minus 6. Oh, gee, that looks pretty simple. What's x? Minus 2. I hope you can agree that that's a really simple point to plot. All right. Let me get my eraser out. And yeah, maybe I shouldn't erase it. Someone says, do you really need to erase that? Not really, but you could erase it if you want to. Simple arithmetic. You can do this stuff in your head if you like. All right, I'm gonna pick another easy number. All right. So I'm gonna pick, I don't know. And you might wonder why I'm doing this. I already did 0, I did 1. Let's see. I'm gonna try minus 2 for y. Isn't that crazy, doesn't it? I'm not saying it's going to work well. I'm saying I'm willing to try it. A lot of students get frustrated by trying. They say they don't want to try. They just want to know exactly what they need to do. And I can't say it's not, you need to try. Furthermore, you need the opportunity to try. You're going to be shocked when you apply for your jobs that you want after school. That's going to be the most heartbreaking thing you experience. They're not going to let you try. You got to start trying. All right. Don't be disappointed when things don't work. Let's see if this works. What do I get? 3x minus 10 equals minus 1. Boy, I don't know if it's going to work. Let's try it. Well, let me write this over here. Keep going. This should be 3x equals, let's see, I take, oh, look, that'd be 9. What's x is 3? All right. I think it's pretty easy, by the way. Are the numbers small? Incredibly small. Typically, and I do say this, I've been teaching her a very long time. Their numbers tend to be quite small. These are really nice. Here's the deal, though. The nice thing about diaphantine, let me put out what I mean about diaphantine. If there is one integer solution to the problem, and there is, there's an infinite number waiting for you to pick off the tree. So someone says, could you have gotten this one? I can. I already did it. Can I get others? Let me go through that with you. As I do this, I want to point out what I'm doing. I'm counting. All right, I can get my eraser out. Erase this business over here. All right. I'm going to tell you what these things are. This is the delta y. And this is the delta x. Some students struggle with this. If you can't do it, try. If you still can't do it, try again and try again until you get it. However, some students have a tough time getting it. If we have integers, though, it should be incredibly easy to count on. If you're at -2 and all of a sudden you get to 1, I hope you can agree you went up by 3 solid units. All right, let's do the delta x now. If you're at 3 and you arrive at -2, you went down 5 units. All right, I'm going to count the y's because 3 is smaller than -5. Going up by 3, right? What's the next number going to be? Well, what's 1 up 3? 4. Could I continue to go up? Of course I could. 7, 10. I got to be honest with you, though. Typically, I don't want to go off my fingers. I really don't. All right. Let's do the delta x now. All right. So if you're at -2 and you go down 5, I hope you can agree you'd be at -7. If you're at -7 and you go down 5, I hope you can agree you'd be at -12. If you're at -12 and you go down 5, I think you could agree we get to -17. By the way, I don't know if these are true. I want to see if they're true. I'm going to check them. Where do you check? In the original. Let's see if this is true. What's 3 times -7? -21. Plus, what's 5 times 4? 20. Does that give you -1? Yes. Let's check this one. What's 3 times -12? -36. What's 5 times 7? 35. Does that give you -1? Yes. Let's try this one. What do you get? What's 3 times -17? Let's see, -30, -51. What's 5 times 10? 50. Does that give you -1? Of course it does. All right, let's talk about easy points to plot. If I were plotting this, I would plot this, and I would plot this. I would avoid the other ones because it's too much counting. It's up to you. We will go through examples, though. When you're doing examples, though, I want to claim, even if this problem said graph it using the x and y intercepts, I'm still going to claim you should be looking for easy points to plot. If you do that, you're still going to get the x and y intercept plotted correctly. And we'll go through that. We'll do examples next. All right, thank you.